Hey, welcome back to example 4 for section 5.4. In this example, we're just going to observe a graph and analyze it and then come up with the sinusoidal function that represents the graph. Okay. So when it says sinusoidal function, it doesn't mean it has to be a sine function. It could also be cosine too. So either of those will work. What I like to do is analyze the graph and see which one's going to be easiest, because I don't always like doing a phase shift. I find that's an extra step that if you can avoid makes it a little bit easier to do. Okay, so we're going to need all these parameters, right? Whether we do sine or cosine, we're going to need A, K, D, and C. So I'm just going to mark up the graph a bit here. My center line is right here. This is C, and it's at -1. That's kind of halfway through the graph. I can see that we have an amplitude of, it looks like 4 units, because we go 4 units to the maximum. I can also see the period. So if I'm starting here at the center line, that's 1 full cycle. It's at 120 degrees. Okay, and we'll worry about the phase shift later. So if the period is 120, what I can take away from that is the period equals 360 over K. 120 equals 360 over K. Well, K must be 3. So we now have values for A, K, and C. Okay, the next thing I want to do is decide if I actually want to use sine or cos. I like that this is beginning at the center line. That's usually a good reason to start with sine function, because cos always begins at a maximum. Okay. The thing though with this is that it's actually going down, and it's not starting at the center line going up. Because it's going down, that actually means it's been reflected. So I can just use a negative value for A, and that would cover that part of the graph. So we could go ahead and we can start modeling this. So I'm going to do -4 because it's reflected. It started at the center line going down. That's why I use the negative. We'll leave it as sine. My K value is 3. I actually don't need a phase shift because we did the reflection instead. Everything's going to line up. And plus C is -1. So we got to write -1. So this equation will work perfect. Okay. I'm going to write or. I'm going to give you one more that would work. We'll use a cosine function. So for cos 3x, there is going to be a phase shift. Then we got -1. So cos would actually begin up top, right? And then work its way down. So in order to line up with the black graph, I would need to take this and I would move it over to that max point up there. That's kind of how I always figure out the phase shift. I look at what function I'm using and I draw how it starts, and then I make it match the other graph. So we'd have to go over 3 to the right. That's actually lines up with 90. So we have to go 90 degrees to the right. So I'll write -90. Okay. And I use +4. That's why I began at the top, right, going down. If I would have used -4, then I would have had to start down here and work my way up. I would actually have a smaller phase shift. It would only be, to get to this point, it would only be 30. So that would also work. Okay, now it just says check your equation using a graphing calculator. So we'll get rid of these and we'll add the 2 that I did. So -4 sine 3, another bracket x. I guess we didn't really need the bracket there, but -1. Okay, that's the first one, and that looks just like the picture. My maximum value is at 90, again at 210. My intercepts are at, well, I guess we don't really know what those are, so that's not really that important. Okay, but the amplitude looks good. It looks like it's at a height of 3. My minimum's at -5. So that definitely matches the information. Let's try the second one. Okay, and there you have it. They're both the same function. Okay, so there's also 2 more that you could write that would fit this as well. They would just have different phase shifts. Okay, that's it for this lesson. Hope this has been helpful. I'll see you guys later.